I welcome to this 4-week MOOC course on analog electronic circuit. Welcome to the second week. The first module is mid-frequency analysis of RC coupled BJT amplifier. So seen here, the diagram is there in the front page, the RC coupled BJT amplifier. So we can see here a single stage BJT RC coupled amplifier and its frequency response analysis. So voltage source in series with a series resistor. Because it is called as RC coupled, it is coupling to the next stage through R and C. It can be given as input to the next stage. So that's why it is called as RC coupled amplifier. And this is the self-bias circuit configuration. External capacitors CC and CC and CE. So we'll see the exact the diagram what we have seen in the previous session will be copied down in the case of transistor in the next slide. So this is the small signal AC analysis of and substitution of BJT electrical equivalent circuit. So RS, VS connected to ground, coupling capacitor. RB is parallel combination of R1 and R2 resistor connected to ground. This is the diagram of BJT, the simplified diagram we have seen in the previous session. RBB dash, RB dash E, C, and the voltage across this parallel combination of resistor and capacitor is VB dash E, dependent current source parallel with the capacitor. Then at emitter terminal we have RE parallel with the CE, and output side RC connected to ground, capacitor, then RL. So see here, the thing given here is that internal capacitors C and CB-C, these two, as a shunt element in combination with adjacent resistors, acts as a low-pass filter. External capacitors CC, CE, and CC, in combination with the series element resistors, will form a high-pass filter. So we'll see the three different analysis: mid-frequency analysis, high-frequency analysis, and low-frequency analysis. So see here, the above circuit diagram can be simplified and can be seen as that is high pass filter because of external capacitors CC, CC, and CE. The overall amplifier with the gain AV mid-frequency, the mid-frequency voltage gain, and low pass filter action is because of internal capacitors C and CB-C. So from high frequency, from the high pass filter, because of external capacitors, high pass filtering action. So means it is high, it allows high frequency components. So that cutoff frequency can be seen from F1. That cutoff frequency can be seen from F1. This is high pass filtering action. And the low pass filtering action is because of internal capacitors, the internal high frequency capacitors of BJT, C and CB-C. So you will calculate CB-C. So the overall frequency response is divided into three parts: mid-frequency analysis, low-frequency analysis, and high-frequency analysis. In this lecture, we'll see the mid-frequency analysis of RC coupled BJT amplifier. So these three configurations, low, middle, and high frequency. So we have seen that because of external capacitors, low frequency components are not passing through the system. So internal capacitors will act as an open circuit, and effect of the external capacitors need to be estimated and calculated as F1. And we can see that the C and CB-C values are very high. Say example 1 picofarad. So if you calculate the impedance of that capacitance at low frequency, say 1 kilohertz. So 1 by J 2 pi F into C. F is 1K, C is 1 picofarad. So 1 into 10 power 3 into 1 into 10 power minus 12 becomes 10 power minus 9. It comes to the numerator 10 power 9, very high resistance. So we'll consider it as an open circuit in low and mid frequency analysis. But its effect need to be calculated in the high frequency region. So while doing the mid-frequency and low-frequency analysis, the external capacitors are considered to be a short circuit. So this diagram is very much useful for the analysis of low, mid, and high frequency. Finally, we'll calculate the bandwidth of the RC coupled amplifier, which is equal to F2 minus F1. So, as discussed in the previous table, first we are discussing mid-frequency analysis. All external capacitors are short circuit, internal capacitors are open circuit. From the previous diagram, all the capacitors have been eliminated in this circuit. So, VSRS, RBB dash, CB dash E is eliminated, CC is eliminated, and CE, the bottom side, that is at emitter side, has been eliminated. That is short circuit. And GMVB dash E parallel with RC. Here actually capacitor, external capacitor should be there. Here internal capacitor is there. Internal capacitor is open circuit. External capacitor is short circuit with RL. So we are considering here RL dash is a parallel combination of RL and RC. And at the input side, we have neglected RB. Why? Because RB parallel with HIE. RB is a very high value, parallel with a low value always leads to HIE. So we are calculating the output voltage. The current IL is flowing through the load resistor. V0 is equal to IL into RL dash. That is output voltage. RL dash is RL parallel with RC. But the dependent current source and load current are opposite in direction. So we can say IL is equal to minus GM VB dash E. So we'll substitute this in this equation. So IL is equal to minus GMVP dash E. We are substituting in V0. So V0 is equal to minus GMVP dash E RL dash. Now towards the input side, the current flowing through the circuit. The current flowing through the circuit, we have denoted it as II. One voltage source are there, three resistors are there, and VB dash E is the voltage across RB dash E. So we have written here II is equal to total voltage is Vs divided by Rs plus RBB dash plus RB dash E. And from the conversion formulas, which I have not discussed in the lecture, but RBB dash plus RB dash E is HIE. So we denoted VB dash E is the voltage across RB dash E resistor, current multiplied by RB dash E. So Vs into RB dash E divided by Rs plus HIE. Substituting this in the equation number 9 in place of VB dash E gives V0 is equal to minus GM. In place of VB dash E, we are substituting this equation. Vs into RB dash E divided by Rs plus HIE into RL dash. So Vs has taken back here. V0 by Vs is a mid-frequency voltage gain. We are discussing here mid-frequency. So answer is minus GM into RB dash is called HFE. HFE into RL dash by Rs plus HFE. This is the mid-frequency voltage gain. AVMF is equal to minus HFE multiplied by RL dash divided by Rs plus HIE. This is the mid-frequency analysis. In the next lecture, we'll see the high frequency model and external capacitors effect, internal capacitor effect. We'll discuss there. So that's all, the end of lecture 4, the mid-frequency analysis of the BJT amplifier has been